Yeah, warm good morning, friends. This is a lecture series about failures. Then first we start with brittle failure, and in previous videos we have spoken about other failure types. We will start with first brittle failure. Okay. The brittle failure is a type of failure characterized by a little or no plastic deformations before fracture. When this material undergoes brittle failure, it typically breaks suddenly without any warning once the applied stress exceeds the critical value. It is known as the material's ultimate tensile strength or fracture strength. Right? There are several factors that contributes to brittle failure. The first one is material property. When we take material property into concern, some materials are inherently more prone to brittle failure than others. The materials with high strength and low ductility are more likely to get fracture in this brittle manner. And the examples of this type of brittle materials includes ceramics, glass, and certain type of polymers, and some metals at low temperature. Second one is stress concentration. Stress concentration, which occurs at points of geometric irregularities or flaws in the material, can significantly reduce its resistance to fracture. So the notches, sharp corners, scratches, and surface defects are the examples of, that can promote brittle failure by acting as a stress concentrator. The third one is temperature. The temperature at which the material is subjected to stress plays a crucial role or a vital role in determining the failure mode. Some materials may exhibit ductile behavior at high temperatures, but it becomes brittle at low temperature. This is a particular evidence of brittle to ductile to brittle transition, and due to this, significantly the material properties will affect, or there will be a change in material behavior. The fourth one is loading condition. The rate at which the stresses applied to a material can influence its failure mode. In many cases, you can see the material is subjected to rapid loading, such as impact or shock loading, and it is more likely to fall in brittle manner due to its insufficient time for plastic deformation to occur. And the fifth and final one is microstructure. The microstructure of a material includes factors such as grain size, grain boundaries, defects that are present in the material, and it also influences susceptibility to brittle failure. For example, if a material with coarse grains or brittle phases dispersed with a ductile matrix are more likely to exhibit a brittle behavior. So the brittle failure is often characterized by the propagation of cracks through the material, leading to sudden failure. This type of failures can be catastrophic, especially at structural components where sudden failures without warning can cause us severe consequences. And understanding of this type of failures, so for understanding this type of failures, there are some factors that including ductile to brittle transitions, and the microstructure, which is predominantly appear on a material, loading rate, and also the temperature at which that loading happens, and the stress concentrations. You can see in some of the materials which is employed in a particular application, when it is go on or moving on or employed in a particular application, that even as the time goes, we can see there may be some scratches or notches that are present, and that too, if a material which have sharp corners and notches are one of the stress concentrators where the ductile failure starts. And that too, we can see in most of the materials we are using chamfering or chamfering process in order to avoid the sharp edges, as we think that is an aesthetic purpose, but it is the main stress concentrators for the brittle failures to occur. Therefore, the understanding of the factors including brittle failure and implementing appropriate design and the material selection strategies are the important or otherwise known as are essential for preventing these types of failures in engineering applications, which because they are more catastrophic, they don't give any warnings. So take into the consideration, brittle failure is very it causes a lot of damages without any warning. So identifying the